Okay, question 7 on the trapezium rule. That's normally quite a straightforward topic, the trapezium rule, usually worth about 4 marks in an exam. So if you are struggling with the trapezium rule, I think it's probably a good idea to do a sketch. So if I do a sketch here of this question, the equation y equals log 2 plus x, it's the log x graph, but it's just been shifted 2 to the left. So it's going to look something like that. So just label that y equals log to the base 10 2 plus x, and we're going between 3 and 5, so we'll just do that 3 there. Let's do that. I'm just making a bit more room here. I know this isn't really to scale, but I'm going to need the space in between to write in a minute. And it says we need 4 strips or 4 trapezia. So if I split that up here, by the way, you don't need to do any of this. This is you can just go straight to using the formula in the formula book and just substitute some values in. But if you are having trouble understanding it, then do a sketch like this until you get the hang of it anyway. So this would be 3.5, this would be 4.5. So these, we're just going to find the area of all these trapezia and add them up, basically, and that is going to be our estimate for the area under this graph between 3 and 5. So what we want to do is to find all these heights, which are y values. So that would be y0, this is y1, the height here, this is y2, this is y3, this is y4. We need to find the heights of all of these. Obviously the width here is going to be 0.5. When you use the formula, that's what h is, the width of each trapezium. This here, y0, is just the value you get when you put in 3 into this equation. So when you put 3 into the equation, you're going to get log 5. I'm not going to write the base 10. It's just assume it's base 10 if you don't see any base written down anyway. So when x equals 3.5, you're going to get log 5.5. This is going to be log 6. This height y2, y3 is going to be log 6.5, and this will be log 7. So those are the heights of those are the values of y0, y1, y2, y3, y4. Now if we look at the formulas in the formula book, our integral from 3 to 5 of log 2 plus x, it doesn't exactly equal the area of all these trapezia, so you should do approximately equal to symbol, which I've tried to do there. So that will approximately equal what it says in the formula book, which is a half h y0. Now we're only going up to y4 here, we don't need to go any higher than that, plus 2, and then we're doing y. Let's just see if I can rub that out. It's 2 times by all of these, so that's y1 plus y2 plus y3. So you always, when you do the trapezium rule, you add up the first and last y ordinate, which is this and this. But then if you look at, when you're doing the trapezium rule, it makes sense that you need to use the middle ones twice. So you're going to use that twice, you're going to use that twice, you're going to use that twice, because, well, just look at the trapezia. When you find the area of this trapezium here, you're going to use the y1 value, and same when you use find the area of that trapezium, you're also going to need to use the y1 value. So that's why you need 2 of the middle values, the y ordinates, but only 1 of the end values. So all you need to do now is stick those values into the equation. So we've got half times by 0.5 times by the y0 is log 5, y4 is log 7, and then we want to add 2 to all the other values, so multiply by 2 all the other values. Let's just get rid of this, and so we need 2 of those, we need 2 of these, and we need 2 of these. And then you can just type this into your calculator. It doesn't say leave it exact, it says give your answer to 3 significant figures. So if you type that all into your calculator, you'll get 1.55173 something. And so we can say that's 1.55 to 3 significant figures. For part B, we've got to use our previous answer to get an approximate value for this here. I've left the answer up for part A because it's going to help us out, I think, for part B. In part B, the only difference between the questions is that square root. And as I'm sure you know, when you square root something, it's the same as doing that to the power of a half. So comparing the 2 equations, this one and this one, all we need to do is move that half using the laws of logarithms. We can move that half to the front, and then the question we're trying to find becomes just a half of the previous question. So if you look at what we have now and you look at what we did in part A, they are the same. So we know from part A that this equals this. So all we have to do in part B is do half of the answer to part A, which was 1.55173. Try and keep that exact if you've still got that on your calculator. So 1.55173 and so on, and we'll give that to 3 significant figures, just like the previous question, although it doesn't actually say. I'm assuming that 3 significant figures will do.